Hello, how do we solve for x in this equation? Solution. We can write this as 3 raised to power x equals 30 minus x when we transfer this to the right hand side. Now let's divide both sides of this equation by 3 raised to power x. So we're going to have 3 raised to power x over 3 raised to power x equals 30 minus x over 3 raised to power x. Obviously this cancels this, so we have 1 to be equals 30 minus x over 3 raised to power x. So we're gonna have 1 to be equals, when this goes to the numerator, we're gonna have 30 minus x times 3 raised to power minus x. That is, whenever we have, let's say we have 1 over a raised to power n is simply the same thing as a raised to power minus n. So that's how we got this. Now let's make this exponent looks like the coefficients. So what do? So we just multiply both sides of this equation by 3 raised to power 30 times 1 equals 30 minus x times 3 raised to power 30 times 3 raised to power minus x. Nothing has changed. So we're going to have 3 raised to power 30 on the left equals 30 minus x. When we combine these two, so we're going to have 3 raised to power 30 minus x. Now, recall that exponential ln k is equals to k. So let's say our k is 3. So we're going to have exponential ln 3 is now equals to 3. So using this property for this 3, so let's proceed further. We're going to have 3 raised to power 30 equals 30 minus x times. So we're going to replace 3 with this guy. So we're going to have exponential ln 3 times the exponent, which is 30 minus x. So this implies that 3 raised to power 30 equals 30 minus x. We can write this guy as exponential 30 minus x times ln 3 by laws of indices. So now let's make this coefficient looks like the exponent. So we just multiply both sides of this equation by ln 3. So we're gonna have 3 raised to power 30 times ln 3 equals 30 minus x times ln 3 times exponential 30 minus x times ln 3. Nothing has changed. Now let's take the Lambert W function of both sides. So we're gonna have w of 3 raised to power 30 times ln 3 equals w of 30 minus x times ln 3 times exponential 30 minus x ln 3. Now recall that the Lambert W function is given by, let's say we have w of a exponential a. It's simply the same thing as a. This guy, we're gonna have w of 3 raised to power 30 ln 3 equals, by comparison, you will observe that we have w, this is a is just 30 minus x times ln 3. We have e, which is the Olympiad function. We have a, which is 30 minus x times ln 3. So using this condition, we're gonna have 30 minus x times ln 3 because that's just a. So this implies that w of 3 raised to power 30 can be written as 3 raised to power 27 times 3 raised to power 3 times ln 3, which is equals to 30 minus x times ln 3. So this implies that we have w of 3 raised to power 27, 3 raised to power 3, that's just 27, times ln 3, which is equals to 30 minus x times ln 3. W of 3 can be written as exponential ln 3. That is from our first property. Second property, exponential ln 3 is the same thing as 3. So we just replace 3 with this guy. So we obtain this times the exponent, which is 27, times this guy, which is, let's just put the bracket 27 ln 3, which is equals to 30 minus x ln 3. So we're gonna have w of, applying rules of indices to this guy, we're gonna have exponential 27 ln 3 times 27 ln 3, which is equals to 30 minus x ln 3. That is, we just use 27 to multiply in 3, we have this. So let us rewrite this guy. We're going to have w of 27 ln 3 times exponential 27 ln 3, which is equals to 30 minus x ln 3. Now, let's recall the Lambert W function. It says that w of a exponential a is simply equals to a. So using this property for this guy, you observe that a is 27 ln 3. We have the exponent. We have a to be 27 ln 3. So this implies that this whole guy is simply 27 ln 3, which is equals to 30 minus x times ln 3. Obviously, ln 3 cancels ln 3. So we are left with 27 equals 30 minus x, which can be written as x equals 30 minus 27. This implies that x equals 3, which is the required solution. So let's check if what we have done is right. This is our original question. We have 3 raised by x plus x to be equals 30. So we just plug in the value of x here, which is 3. So let's check. You're going to have 3 raised by x plus x equals 30. So let's just plug in the value of x here. So we're going to have 3 raised by 3 plus 3, which is equals to 3 raised by 3, that's 27, plus 3, which is equals to 30. That is exactly what we have on the right hand side. So therefore, our value of x is equals to 3.